Another question about blood. A 14-year-old girl presents to a pediatrician with a history of fatigue and denies any symptoms of dizziness, pallor, and shortness of breath. Okay, so genetic testing reveals a mutation of the beta-globin gene that results in substitution of lysine residue with a neutral amino acid, reducing the positive charge of 2,3-biphosphoglycerate. Okay, that's the huge important thing. So 2,3-biphosphoglycerate is something that lets you release that oxygen. And if you reduce the positive charge, it no longer work and it doesn't let you release the oxygen anymore. Now, it says which of the following types is most functionally similar to this patient's mutated hemoglobin. So the mutated one does not work as well. It's not letting go of the oxygen, and that's very similar to fetal hemoglobin because you're stealing the mom's you want to steal the mom's oxygen. You want to latch onto it super tightly. And so that's going to be the reason why it's fetal hemoglobin. So we know that's our answer. But our big question is, what are the other ABDE going to be associated with? So let's dive into these. Okay, hemoglobin A1C. So you probably have heard this in association with diabetes. So that's formed when glucose attaches to hemoglobin A in diabetics. So you get HbA1c. So when glucose attaches to the hemoglobin, it doesn't change the binding affinity very much, and it doesn't mimic HBF. Hemoglobin C, option B here. That is a mutation which replaces glutamate with lysine, and it causes crystal formation in red blood cells and a mild hemolysis. It doesn't affect oxidative affinity. Hemoglobin H. Okay, so H here. That's found in alpha thalassemia. So that's excess beta globin forms tetramers, and that has a high, extremely high oxygen affinity, even higher than HbF, and it doesn't bind the same way as HbF. Hemoglobin S, that's sickle cell. Okay, so that's going to be glutamate replaced by valine, forms long polymer chains and causes the sickling shape of the red blood cells, and oxygen affinity is normal or slightly decreased. So our recap, they've got this weird mutation which reduces the binding affinity, and let me show you a little graph here. Boom! Okay, that's kind of out of focus a little bit, but yeah, you are going to be shifting it to the right whenever you have functional 2,3. But if you have non-functional 2,3 beta-phosphoglycerate, then it's going to be moving to the left. So it'll not be able to let go, and since it can't bind well, it can't let go. It holds oxygen too strongly, and that's just like HbF does in babies to steal the oxygen from the mother's blood. So hopefully that helped. If it did, then like and subscribe. If it didn't, then unlike and unsubscribe and delete YouTube and form your own channel.